Okay, so like I said, this is a chance for you to wipe your slate clean if you've been struggling with the algebra. We're starting into geometry. So we're going to start in Module 5. Okay, and Module 5 is about geometry. In fact, Modules 5, 6, 7, and 8 are about geometry. Okay? We will be moving at a faster pace because you guys should be picking up on this a little bit quicker. Should be a little bit easier. And it's not algebra. It's more of a visual type thing. So that's what we're going to be doing. Today we're probably be doing a lot more hands-on stuff with the geometry. Okay? We're going to be doing a little activity today that's hands-on. All right. So I want to start off talking about this question right here. How do you know something is true? And I'm talking about, well, it could be anything really. How do you know when something is true, you guys? Say that again? Factual evidence. Okay, so sometimes we know by factual evidence. Okay, let's write that down. Oops. Okay, what else? How do you know something's true? How have you learned some things are true in your life? Like, yes. Okay, so when you say that by doing it, you've done something over and over again, and every time you do it, the same result comes out. Yeah, trial and error. I'm gonna write it down in a little bit different way. Just trying it out with multiple examples, right? And because I'm gonna put it in a geometry sense. Okay, so that's a good one right there. Trying it out. With multiple examples. I want you guys to write these down so you can refer back to them. Okay? Now, the one up here, factual evidence, the way they say it here is making an argument based on previously proved statements and logical ways of reasoning. And that would be the same thing as factual evidence, okay? Okay, so there's two of them. There's four of them. What was that? Researching, yeah. I think that fits into probably that one right there, doesn't it? Okay, researching. Okay. What else? Any ideas? Andrew's given all our answers so far. Anybody else got an idea? How do you know something is true? What was that? That's the one I'm looking for. Yeah, you didn't say it loud enough, I guess. I'm going to write it a little bit different way than she said. Accepting it on authority, right? Do we do that sometimes? I think we do that all the time. Everybody does that. You hear a scientist has done research on something, and he states that such and such is true. And do we believe it? Most of the time. Not always, but most of the time we believe what they're saying is true. We accept things on authority. Okay? Got one more way. And this one's probably not a whole lot different than the other ones. The last one is making an argument based on a diagram or representation. Okay? So, making an argument based on a diagram. Okay? And I think this one's almost like looking at examples and stuff like that. Okay. We kind of got that? Now, basically it boils down to different things, you guys. There's something called inductive reasoning and deductive reasoning. I want you to know these two words, inductive reasoning and deductive reasoning. Okay? We're going to do both of these today. Okay, so what are these? Inductive reasoning is basically the process of examining many examples noticing a pattern and stating a conjecture. That's what it is. Did you guys know that you do this every single day of your life? You do inductive reasoning every day of your life. There's some doors that you walk through and you just walk through them and you know, and you don't turn around to close them. Why don't you turn around to close them? Because why? Oh, okay, other people got to come through. But let's say you're the only one going through. Why don't you turn around and close it? What? Because it automatically closes, right? You have doors. In the old school, this worked out really well because every door in the school, when you'd open it, it would just automatically have shut because they had springs on the hinges that would automatically shut it. In this school, now you guys forgot what that means because you go out a door right there and you have to turn around and shut it if you want it shut, right? And so it's a little bit different, but you know by having gone through that door several times that it's going to automatically shut behind you. There's certain doors that do, right? A lot of, like the doors going outside of the school. Do you turn around and shut those? No, because you know they're automatically going to shut, right? You do this when you see people. You make judgments about them, right? And you do this because you examine a lot of the things that they do and the examples of them. You notice a pattern, right? You notice a pattern about it, and you make a conjecture. What's a conjecture? Well, actually, conjecture, well, yeah, you make a judgment that something's true based on the examples you've seen, okay? So kind of like that. So you guys make, the door example. You made the conjecture that door is automatically going to shut behind you. You don't have to turn around and shut it, right? Okay, but you do this when you see people, you watch them. I've got to try and think of some more things, but there are examples all the time that, if you throw a rock in the water, what's going to happen to it? It's going to sink, right? It's going to sink. And you know that. Unless it's what kind of rock? Pumice. And that would be what we call a counterexample, and we'll talk about that later on, that proves it's not true. Okay? Now, can you prove things are true by inductive reasoning? Because you're just looking at a bunch of examples, and every example you try might be true, right? But have you tried every single example there is? No. So could there possibly be an example out there that's not going to be true for that? Yeah, just like pumice is not going to sink to the bottom. It will float, right? And it's a rock, though, right? And so not all rocks. So you might have made the conjecture that all rocks sink when you throw it in the water. But all of a sudden, pumice shows you that it's not. Okay, so you can't always prove things are true, but can you be reasonably sure some things are true that way? By following a pattern? Yes. Okay, and what's deductive reasoning? Okay, I'm going to write this one down. Okay, I want you to write it down too. This one's really important right here. The process starting with statements. Assumed or accepted as true. And that's because you've already proved that they're true through deductive reasoning, okay? Then creating a logical sequence of statements. Until we arrive at the desired conclusion. Oops. In other words, when you do something by deductive reasoning, you know it's true afterwards. So scientists have theories, right? Is a theory known to be true for sure? No, what are they trying to do with the theory? They're trying to prove it's true. So they come up with theories based on inductive reasoning. They see many examples, and they notice a pattern, and so they state a theory. A theory is the same thing as a conjecture, okay? Thank you. Do I just give this to Sydney? Because it says to her parents. Guess you get to decide whether you give it to him or not. All right. Okay. So, scientists will notice something. They notice a pattern. They state a theory about it. Conjecture and theory are the same thing. Okay. So, if you want to write down by this, theory. So it's kind of scientific. And then they try to go through some reasoning, some proofs to show that it absolutely is true. And once they do that, and they can prove that it's true, then they no longer call it a theory, they call it a fact. Okay? It becomes fact rather than a theory. Okay? Any questions on that? It's kind of boring stuff, huh? Okay. I want to ask you guys this. Have you learned this before? What do the three angles of a triangle add up to? Raise your hand if you know. Just don't say it out loud. How many of you know what the three angles of a triangle add up to? Half of you? Okay, what do you guys all think? Say it out loud. 180, right? Do you know that for sure? How do you know it for sure? Okay, so is it factual evidence? Did you try out multiple examples? Did you accept it on authority? Or did you make an argument based on a diagram? All four of them? Okay, we're going to do this today. I think most of the time we know because some math teacher told us, right? Or wait, where was that? Accepting on authority. We did it because we believed that the teacher was right. Okay, and the teacher might have even made us do this right here. They might have tried it out with multiple examples. Okay, that's what we're going to do right now. Okay, so we're going to make. So we've taken our piece of paper. You guys fold it in half, you cut it, so each of you have a half paper. Okay, so this is colored paper. What I want you to do is some of you are going to, don't draw this yet. You're going to draw a large triangle. Yeah, I want you to use a ruler because I want the sides to be exactly straight. So some kind of straight edge. It doesn't have to be a ruler. If you have a straight edge at your table, like that, you can use a corner or something. Or I have rulers right here. Now, I want one person. Now, some of you guys have 4 people, so 2 people can do the same thing. I want some of you to draw an acute triangle, some obtuse, and some right. I want at least one person at each table to do one of those. Now, those of you who only have 2 people, you guys, I want you guys to decide. between the four of you, who's going to do what? Two of you can do the same thing. Okay? So you're going to do that right now. One of you use a straight edge to draw either an acute, obtuse, or right triangle. Now I want you to take your triangle, whatever kind of triangle it is, and I want you to shade in just a little bit at the end of each corner. You'll see why in just a little bit. Each vertex, I want you to shade it in. Okay? You can use colors if you want, or you can, if you have some. Okay, so you're going to color in the vertices, and then you're going to tear it so that there's a vertex in each piece. You're going to tear it like this. Don't cut it. Tear it. Tear it. Works better when you tear it. Okay, so you're going to tear it so there's a vertex in each piece. You can tear it in 3 pieces. Probably. Okay, now, in your notes, you might need to turn the page over. You can try this without your notes first, okay? What you're going to do is you're going to take your 3 pieces, your 3 vertices, and you're going to fit your 3 vertices together so that a side, like for example, this side and this side right here have to be edge to edge, and then the vertices have to be vertex to vertex. And you're going to do that with all 3 vertices. Okay? So take all 3 vertices and put them together. So your paper's edge to edge. All 3 vertices, the colored ends, the ones you colored in, and you're going to put them together. Exact. Yeah. Except for they got to be all edge to edge. Yes.
Is Andrew Wilburn in there?
He is.
Could you send him down to the main office?
Okay.
Thank you.
Okay, now. Okay, what I want you to do is everybody compare them at your tables. What do you notice about them when you put them edge to edge? No, I didn't. Oh, you did it wrong. Okay. Yeah, you got to take, so the triangle's in 3 pieces. So you can do this again if you need to. Okay. So what happens when you put all 3 vertices together, you guys? How many of you found out that it makes a straight line? Touch. All right. How do you say your name? Tachihiko? Do you see that? Okay, like that. Okay, good. So how many of you guys notice? I want you to take your ruler. You should have gotten something like this now. You had 1 piece. And there's the shaded in. You had another piece, shaded in area, right? And you have your 3rd piece, shaded in. And you guys all found out, take your ruler, put it along there, see if that's a straight line. It's a pretty straight line. What does that, now, let me take to the next page. Let me ask you guys this. If you were approximating, what would you say the measure of that angle is right there? How many degrees? Okay. Well, what's this angle right here if I go right here to there? Okay, it looks about 9. Does that look like about half of it? Okay. What about this angle right here? Does that look like it's, 90 plus another 45? What about if I put it out here so we went all the way around? How far is that around? 180. So what does 180 degrees make? A flat line. What do the 3 angles of your triangle make when you put them together? A flat line, doesn't it? So what does that show us? That they add up to 180 degrees, right? Now, before we go on to the next part, I want you guys to take and glue these in your notebook. Okay. So, you guys, we just showed that the three angles of a triangle add up to 180 degrees by doing this little exercise. Now, everybody did a different triangle, right? Even those who did right triangles, your other two acute angles aren't going to be the same, right? Most likely. And did everybody get a straight line?
Yes.
So which one of these three things did we do right here?
Trying it out.
So we did this one right here. Now, does that prove it's true? No, it doesn't, right? But we did lots of examples. Are we fairly sure it's true? So we've made a conjecture. So what's our conjecture? Okay, right. Everybody write this conjecture down. The three angles of a triangle add up to 180 degrees. That's a conjecture. Now, we have not proven that it's true, have we? We have not gone through a set of logical, already proven statements to show that it's true. So we can't say that it's true for sure unless you accept my authority that I'm telling you that it's true. Could you do that? And you had other teachers tell you that, right? You've had other teachers tell you right here, accepting it on authority. You've had other teachers tell you that. Okay? But we are eventually going to get, next lesson, we're going to actually make arguments about it based on a diagram. Okay? And then by the third lesson, we're going to come up with what we call some formal proofs to show things like this are true. That's what we're going to work towards. Okay? Any questions? Do you kind of get the idea of inductive and deductive reasoning? And you get the idea that we just did a lot of examples, so we did inductive reasoning, right? We did inductive reasoning. Next time we're going to do deductive reasoning. Well, actually, we're going to start learning how to do deductive reasoning. And the third time, we are going to do deductive reasoning. Okay. Are there any questions on what any of these shapes are on problem number 1 on your assignment? Okay, a parallelogram goes like this. It's a polygon that opposite sides are parallel. You guys know that the arrows, these two arrows, if you got two arrows here and two arrows there, that means these lines are parallel. One arrow here and one arrow there means those lines are parallel. Okay? Yes. We'll get to trapezoid in just a second. This is called a parallelogram right here. Now, a rectangle is a parallelogram, but not all parallelograms are rectangles because a rectangle has 4 90-degree angles. You understand that? Okay? This right here is a trapezoid. A trapezoid has one pair of sides that are parallel. Okay? That's a trapezoid. Any others that you're not sure? What's a cube? Yeah. Like a die. This die right here is a cube, right? Okay? And you know what perpendicular lines are. What are perpendicular lines? Lines that do what? Intersect at what kind of angle? 90-degree angle, right? Okay? All right. I want you to brainstorm in your groups to find examples in the real world of all those 5 things, and then you're going to share some. Okay, so we have a straight angle is made. I'm going to say that one more time for the people at home. Okay, a straight angle is made by taking a radii of a circle going this way and one going exactly the opposite direction. That forms 180 degrees turn right there. Two radii of a circle going in opposite directions. Makes a straight angle. Okay? Number 4. How come it skipped from problem 3 to number 14? I think that's supposed to say 4. How many degrees do you think are in a straight angle? We already answered that question. How many? Okay, write it down. Use features of the diagram to justify your answer. We kind of did that. Okay, go to the top of the next page. If two angles share a vertex together, they make a straight angle. Then the two angles are called a linear pair. Below are 3 examples of linear pair, and I want to talk about these. Okay? So, if I have a straight line, you guys, there's my straight line. I choose a point somewhere on it, and I make a ray going off of it somewhere. Okay? I form 2 angles. This angle right here, right? Does everybody see that? And this angle right here. Okay? These 2 angles add up to how much? 180 degrees. These are called a linear pair. This is, I don't know why students struggle with this, but they forget what that's called all the time. I want you guys to call it's called a linear pair. Why do you think they call it a linear pair? Because it makes a line. Linear means line, right? It makes a straight line. And it's a pair. What does pair mean? It means 2 angles that make a straight line. That's what linear pair makes, okay? And if you want to write that down, 2 angles that make a straight line. And their measure is how many degrees? 180. Now it shows you some examples. Do you see that picture of that bookshelf? They got a divider going up, and then the bookshelf, they form 2 90-degree angles that are a linear pair, right? Then you see those books sitting on that bookshelf at an angle. It forms one book sitting at an angle like that forms 2 angles, right? That add up to 180. Problem number 5, draw at least 2 diagrams of a real-life linear pair. Okay, so everybody, I want you to draw 2 diagrams of a real-life linear pair. I want you to think of something in real life that makes a linear pair. Go. Forgot. I think Amory drew a pool line. Michaela's drawing something else. We're going to find out here in a second. What is this? A clock. Oh, I like that. So at certain times it forms linear lines, right? Probably only at certain times. So she's saying, like when 2 of the hands are going exactly opposite of each other, you're going to have a linear pair. Anytime you get 2 hands of a clock going opposite of each other. Like, it's not going to happen for another 33 seconds, right? Right up here on this clock. And that red hand is pointing exactly opposite of the big hand. You're going to have a linear pair, right? Nice job, Michaela, too. Okay. Kayla and Anne-Marie, good job. All right. Turn it over, you guys. I want to talk about supplementary angles really quickly. How many of you guys know what supplementary angles are? You learned this last year. Okay. So you guys learned last year. Okay, supplementary angles. Brandon said it right there. 2 angles that add up to how much? That add up to 180 degrees. Are linear pairs of angles supplementary? A linear pair of angles. If you have a linear pair of angles, are they supplementary? Yes. Yeah, they're always going to add up to 180. They make a straight line, right? Okay, I'm going to let you finish this. This is your homework assignment. You probably should finish before we go.